Okay, so for 7.1, starting out with chemical formula, it indicates the relative number of atoms of each kind in a chemical compound by using atomic symbols and numerical subscripts. And maybe you don't have the wording exactly that way, but what you have means the same thing. What a molecular formula tells us is the types and numbers of atoms that are combined in a single molecule of a molecular compound. I will make that bigger if I can find my remote. An example would be like C8H18. That represents the atoms combined to make one molecule. If there would be two molecules, we indicate that by putting the number out in front. So the subscripts we know represent atoms in a molecule that are actually covalently bonded together. And then the number out in front, which is called the coefficient, tells us how many of those we have. Notice it is called a molecular formula, which tells you that we are talking about molecules covalently bonded. For ionic compounds, we use formula units. And what a formula unit tells us is the simplest collection of atoms from which an ionic compound's formula can be established. In an ionic compound, we do not have molecules. We have a big lattice made up of cations and anions. And so the formula unit tells us the makeup of that crystal lattice. It tells us the ratio of the cations to the anions. And here is an example for that one. And so we have the aluminum cation that has a +3 charge, and we have two of them. And we have an oxygen anion with a -2 charge, and we have three of those. So that means to make up this ionic compound, we need to have at least 2 aluminums and 3 oxygens. That's the ratio of these ions within the crystal lattice. We are going to begin by looking at ionic compounds. Monatomic ions, and I have the definition here if you don't want to look it up. It is an ion made from a single atom. We know that the prefix mon or mono means one, right? A one-atomed ion. The way that we name these monatomic ions for cations The name is the same as the elements for groups 1A, 2A, 3A, and 3B. And if we look at our periodic table, group 1A, okay, that's the alkali metals. 2A is your alkaline earth metals. 3A, we come over to here, that's this group with aluminum. And 3B, that is the first group here in the transition elements. Okay? So for those particular metals, and we know that metals tend to form cations, right? They have few valence electrons. They want to lose them. And so when they do, they create cations. The name of the cation is the same as the name of the element. That can be a little confusing sometimes. So we have, for example, calcium. And so if we're talking about the atom of calcium, it would just have the symbol for calcium, like this. And we would refer to this as the calcium atom. For the ion of calcium, it would have the charge. It has to have that to indicate to us that it has lost 2 electrons. And we would call it the calcium ion. For these, you have to have the word atom or ion on there so that we know which one we are talking about. For many of the transition metals, we have some altered kind of names. It's not just the name of the element. And this is where your ion chart will come in handy. And so notice that one side of the ion chart are for the positive ions, and the other side is for the negative ones. So right now we are looking at the positive ones. Okay? And so at the top, these are your monatomic ions for the main group elements. Okay, so this is the 1A group. This is the 2A group. This is your 3B group and your 3A group. And notice that the names in here are the same for the ion as they are for the elements. Then we have a section for the D block elements that are also monatomic. Notice these names are not identical to those of the element. So, one of our transition metals, the symbol is Cr, and that represents a chromium atom. That is the name from the periodic table. But if we are looking at the ion, Cr plus 3, when I look on my ion chart, okay, since it's plus 3, that helps me locate it on here, right? Plus 3, it's like, oh, it's got to be in this column. And here's the symbol, exactly like what it was on the paper, Cr plus 3. It has 2 names. Chromium 3, the Roman numeral that's in parentheses after those names is part of the name. It's like when somebody is named, you know, John the Second. That is really part of the name. Or an older name for it is chromic. The older names are in italics, or an italicized script there. So this is 2 different names for the same ion. An older name, and we'll be learning this is a stock system name. Okay, so it can be called the chromic ion or the chromium 3 ion. You will have this chart to use on the test. So at this point, you are not going to have to memorize all of these, but you do need to know how to look them up on the chart and use the names correctly. anions. These do not have the same name as the element. The name is the root part of the element name, but we change the ending to IDE. So for example, when we see this symbol like this, that's representing a fluorine atom. But when it is written with a charge to represent the fluorine atom that has gained an electron, it's now called the fluoride ion. If you look on the other side of your chart, the one that has the negative ions, here we have the monatomic negative ions, and notice that they all end in IDE. So we recognize fluorine, the element, but the ion is called fluoride. Or oxygen, the element, but the ion is called oxide. Or arsenic, the element, but the ion is called arsenide. Okay, so that ending is changed. So it's a little bit easier to know when we're talking about an ion for the anions compared to when we're talking about an ion for the monatomic cations. Okay, so for these, you would always need to make sure that you include the word ion in the name. For the negative ones, it's not quite as important, because we can tell the difference between if we're talking about the atom or the ion. Okay, a binary compound. The word binary makes you think of how many? Two. So a binary compound is when we have a compound that's just made up of two different elements. What you're going to be learning is called nomenclature. The word nomenclature simply means a naming system. And we are going to begin by learning the naming system for ionic binary compounds. There are different ways that we have come to name these compounds. It's kind of like, you know, the English system of measurement and the metric system of measurement. It'd be nice if we could just all settle on using the metric system and not have to worry about the English system. But change does not come easily. And the same thing is true for these different systems of nomenclature. There's an old system, and there's a new system that's called the stock system. And it'd be nice if we could just all use the stock system, but change does not come easily. So you have to learn both. We are going to begin with the old system. And for ionic compounds, it's fairly easy. You are just going to be naming the ions. And if there's a choice of names in the old system, you are using the italicized name. And we will be doing these two as examples. So this is where you are given the formula for the compound, and you're going to be providing the name of the compound. So we'll begin with the first one. All we need to do is to name the ions. So Sr plus 2, it's a positive cation, so I know I'm going to be looking at the positive side of my ion chart. It's monatomic, and it has a plus 2 charge. So here's a column that has plus 2, and there I see that same formula for the cation, and its name is strontium. Then I have the anion. It has a -1 charge, so I go to the negative side, and I find a column that has -1 in it, and I see that ion right there, and it is called bromide. And so the name of this compound is strontium bromide. For the second example, the cation is Pb plus 2. So I go to the positive side, and Pb is not one of the main group elements, so I'm going to be looking down here. I'm on the plus side, and I find a plus 2 column, and I'm looking for the Pb plus 2. And it is down here. It got shifted over. And so it has two names, lead 2 or plumbus. For the old system, which name am I going to be using? Plumbus. Then I find the anion, and I'm on the negative side. Find the Cl -1, and it is called chloride. So plumbus chloride. For that one. Any questions about that? Okay, we are going to skip the stock system name for right now. And we are going to go to the page that says writing formulas from the names. Okay, so now we're going to do the opposite. Okay, for the old system, first you're going to write the symbol and charge for each ion. and the positive cation usually goes first. Okay, so you'll do the symbol in charge for the cation, and then the symbol in charge for the anion, and put the cation first. Then you're going to crisscross down the magnitudes of the charges. You had previously learned how to determine formula units for ionic compounds. It was the three-step process. Remember that? You would draw the Lewis dot picture for the elements, and you would show the transfer of the electron from one atom to another, and then write the ions that were created, and then you would do the formula unit. And you could continue to do that, but I think most of you would like a little bit shorter way of determining that than having to do that all the time. And you may have noticed that when you did that process, it ended up that the charges were just crisscrossed down. And this may be how you actually learned it earlier, like your freshman year or something. But hopefully you understand better now why it's that way. Okay, so we're going to practice writing formulas. Sometimes they'll give you just the name of the elements, and sometimes they'll give you the actual name of the compound. So we'll practice both ways. So if we have the element calcium, we need to see what is the ion that calcium would make. And so you look on your ion chart, and this one takes sometimes a little bit more hunting because you don't always know if you're on the plus side or the minus side. Okay? And when we find calcium, we then see that it has a +2 charge. And so we're going to write that symbol in charge. And then we find chlorine. Now, the word chlorine is not on here. But what word do you suppose you are going to be using? Chloride. And when you find that, you see that the symbol in charge is Cl-1. Okay, so that's step one. We wrote the symbol and charge for each ion, putting the positive one first. And now we're going to crisscross down the magnitudes of the charges. The magnitude means the number part, not the sign, positive, not a positive or negative sign. So I'm going to take this 2 and crisscross it down to here. The 1s, however, we do not write, because it's assumed that if you have this element, you're going to have at least one of them, correct? If you don't have one, then you'll have a number down here, but no number means 1, so we don't actually write the 1. Now, if you were doing this with that 3-step process, we would have come to the same conclusion. Calcium has 2 valence electrons. Chlorine has 7. So we have an electron go there. And then we need another chlorine. And so the other electron would come here. And then we write the ions that we make. Right? And then we wrote the formula. And there were 2 of them. Okay? So remember that process? Okay. So the reason that we need to have 2 chlorines is because we have 2 electrons from the calcium that need a place to go to. Okay, so that's how you would do it if they give you the actual elements involved. Here's an actual name of an ionic compound. It's the same process. We find the symbol in charge for potassium, and so usually it's going to be the positive side first and then the negative side of your ion chart. So I find potassium, and it's here, and its symbol is K+1. And then I find oxide. That's usually going to be your negative ion, especially if it has an IDE ending. And I find oxide, and it is O-2. And then we crisscross the charge. So the 2 comes down there, and the 1 we don't write. Okay. So that's how you do writing the formulas for ionic compounds. There's one thing that we do have to be careful of, and it says, if they already add up to 0, then you do nothing. And we have an example, magnesium oxide. If we look up the symbol and charge for magnesium, it is Mg+2 when you look on your ion chart. It's on the positive side. The more you use this chart, you'll start to kind of learn where some of them are, and it'll go faster. So here's magnesium, Mg+2. And then we have the oxide, which is O-2. These charges already add up to 0, don't they? +2, -2. So we do not crisscross those 2's down. If I were doing this 3-step process, magnesium has 2 valence electrons, oxygen has 6, I only need 1 magnesium and 1 oxygen for everybody to be happy, right? Okay. So I don't need any additional ones. And so if it already adds up to 0, that means that all of the electrons magnesium wants to lose is exactly how much oxygen needs to gain, so we only need 1 of each. Okay, so that's one little thing that you have to remember when you are doing the ionic compounds. Okay, and again, we are going to skip the stock system. And now we're going to look at oxyanions. These are the polyatomic ions that contain oxygen, right? Oxy refers to oxygen. Polyatomic ions that contain oxygen. Notice they're called oxyanions. So these are negatively charged. And if you look on your ion chart, on the negative side, the polyatomic ions that are listed, most of them are oxyanions, right? Almost all of them, there's a few exceptions, like this one, do contain oxygen. Okay, so this is where your oxyanions are. The one polyatomic ion that we have on the positive side, you've already learned, ammonium. Notice it's the only one. Okay. So polyatomic ions are almost all anions. Ionic compounds do include the polyatomic ions. And you saw this when we did that test, where you had to draw the pictures. Sometimes they were polyatomic ions. So to determine the name, when you have a polyatomic ion as part of the ionic compound, it's not any different. You are still just going to name the ions and use the italicized name if given a choice. So the presence of these polyatomic ions don't change how we name the compound. And we have an example here. polyatomic ions we put in parentheses with the charge on the outside, and that's how it shows up on your ion chart. So the first one, the cation, is a monatomic ion. So I look on the positive side in the +2 column, and there it is. Oops. Where am I here? There we go. So it's called strontium. And then the polyatomic ion is in parentheses, and it has a -1 charge. So I go to my -1 column, and I have to find that exact same thing, and it is here. And because we're doing the old system, it has 2 different names. We are going to choose the one that is in italics, so bicarbonate. And if we are naming the compound from the formula, again, it's still just listing the ions. Make sure that those polyatomic ions are in parentheses, just like they are on the paper, and the charges go on the outside. So we're still just listing the ions, symbol and charge, and going to crisscross them down. Just make sure that you keep the polyatomic ions in parentheses and the charges go on the outside. Okay, so these are the 2 examples that we're going to do. So this one is called magnesium chlorate. So on my ion chart, I find magnesium, and its symbol and charge is Mg+2. And then chlorate, you have to do a little bit more hunting here because the name doesn't necessarily tell you which column to look in, like -1, -2, or -3. And again, the more you use it, the more you'll kind of get used to where things are. Here's chlorate in the left-hand -1 column, and here is the formula. So it shows it in parentheses with the charge on the outside. And then just like before, we're going to crisscross down the magnitude of the charges. So this 2 comes down, and when we do that, it always goes on the outside of the parentheses. Because what it means is we have 2 of these groups that are covalently bonded together. The 1 we don't write. Okay, then we have ammonium carbonate. Ammonium on the plus side, that is the 1 polyatomic ion that we've learned. You need to recognize, oh, that's a polyatomic ion. So we write it in parentheses. And then we have to find carbonate on the other side. And it is in the -2 column. And this is what it looks like. And then we crisscross down. Okay, so that's ionic compounds. Now we're going to look at covalent molecular compounds. Sometimes they're called binary molecular or binary covalent. Those are all names for the same thing. So if binary molecular is not on your notes, make sure to put that on your notes as one of the names, binary molecular. This is what it's called on your quiz. So you want to make sure to have that on there. So again, we are dealing with binary compounds. So these are compounds made up of just two elements. And we'll start with how to name them. And we are starting with the old system, which is also called the prefix system. On page 212, there is a chart, and you need to learn these prefixes for yourself. A lot of them you know, like the prefix for 1 is mono. The prefix for 4 is one that you may not use. It's tetra. Okay. So if you want to jot those prefixes down at some point in your notes, fine, or just make sure that you have the page number there. You will need to know those for yourself. The less electronegative element is first, and when naming it, you use a prefix to say how many there are, but not if there's just one of them. So the less electronegative element is first, and when naming it, you will use a prefix unless there's only one of them. And I think the bell is about to ring.